So now we're going to look at setting up linear equations, systems of linear equations for application problems. So in this case, David borrowed a total of $10,000 to pay for his final year of graduate school. He borrowed part of the money through his school with a Perkins loan that charged 5% simple interest per year, and the remainder of the money from his aunt at a rate of 1.4% simple interest per year. At the end of the year, he paid $428 in interest. How much did he borrow from each source? So if we look at it, he borrowed from Perkins and he borrowed from his aunt. Okay? He borrowed a total of $10,000. So let's just say that we let X equal his Perkins, and we let Y equal the amount he borrowed from his aunt. Okay? So that means that his aunt is going to become Y, and his Perkins is going to become X, and those two added up gave us $10,000. Well, we know some other information. The Perkins charged 5% interest, simple interest per year. So that's going to be 0.05, because remember you have to change percentages into a decimal, times the amount that he borrowed from Perkins, plus his aunt charged 1.4% interest, so that's going to be 0.014 times the amount that he borrowed from his aunt. That total is equal to $428 each year. Okay, so I have these set up. I can do this in a couple of different ways. Again, I can either do addition, which means I would have to multiply one by or both of the equations by an amount, or I can use substitution. I'll be honest, whenever I have variables that have a leading coefficient of 1, a lot of times I'm going to use substitution because I don't want to deal with these decimals and all that. So I'm going to come down here. X plus Y is equal to 10,000. It doesn't matter which one I solve for. So let's just say that I solve for Y, so I'm going to subtract an X from both sides. And I get Y is equal to $10,000 minus X. Okay? I'm going to substitute this in for my Y of my opposite equation. Make sure you do the opposite equation, okay? So that means I'm going to start with 0.05x plus 0.014 times this right here, 10,000 minus x, and that's going to give me 428. So I'm going to distribute the 0.014 in here, and that's going to give me 140 minus 0.014x. And don't forget, I still have this 0.05x on the front. So I'm going to combine like terms, and I get that 0.036x plus 140 is equal to 428. So now I need to subtract the 140 from both sides, and I'm going to get that we have 0.036x is equal to 288. I need to divide by 0.036 both sides. And so we get that x is equal to 8,000. I need to plug this back in over here, okay? So I'm going to take this and plug it in back over here. So I have y is equal to 10,000 minus 8,000. So y is equal to 2,000. Now we're not finished because we just have x and y. We have to put it back in for what our values actually meant. So notice that x was how much he borrowed from Perkins and y was how much he borrowed from his aunt. So David borrowed $8,000 from Perkins and $2,000 from his aunt. So anytime you have an application problem, don't forget to put it back into sentences. We have to address what it actually means. So let's look at another problem. A plane flies from Atlanta to Los Angeles against the wind in 5 hours. The return trip with the wind takes only 4 hours. If the distance between Atlanta and LA is 3,200 kilometers, find the speed of the plane in still air and the speed of the wind. So it's telling us to find two different things. It's telling us to find the speed of the plane. So that's my x. And my y is also telling us to find the speed of the wind. So especially whenever it's telling us to find two different things, those are usually our x and our y. Okay? Now, one thing that you have to know about this type of problem is that distance, d, is equal to your rate times your time. So I'm going to set up a little bit of a table here for my distance, my rate, and my time. Now we know that going from Atlanta to Los Angeles was against the wind. So that's against the wind. And then we know the return trip was with the wind. The distance for both directions is 3,200 kilometers. The rate, well, we're going to start off with the plane's speed, okay? And we have to, plane speed, not the speed of the wind. So let's go back, and it's the plane speed that we're going to look at. And then if we're against the wind, that's going to be a subtraction because it's slowing us down. If we're with the wind, we're speeding up, okay? And then it's not x, it's y. So x minus y is against the wind. X plus y is with the wind. The nice thing is we already know our time. So going against the wind, it took 5 hours. The speed with the wind took 4 hours. So we have our chart filled in. Remember this formula. Distance, 3,200, is equal to the rate, x minus y, times the time, 5, for our first equation. Second one is going to be 3,200 is equal to x plus y times 4. Okay? Distribute your 5 here, and you get 5x minus 5y is equal to 3,200. Here, we get 4x plus 4y is equal to 3,200. We have these two equations right here. We have this one and we have this one. And we're trying to solve for x and y. I don't have a 1 as a leading coefficient for any of it. So what I'm going to do is I'm going to try to make these numbers equal, just opposite signs, which if you notice the y's are already opposite signs. So I'm going to multiply the first equation by 4 and the second equation by 5. Doing so will give me a negative 20y and a positive 20y. So 3,200 times 4 gives me 12,800, and that's equal to 20x minus 20y. Then I have 5 times 3,200, which is 16,000, is equal to 20x plus 20y. Now, if you'll notice, these have opposite signs, same number. So I can actually add these two equations together. Those two will cancel out. 20x plus 20x gives me a 40x. 12,800 plus 16,000 is going to give me 28,800. I'm going to divide by 40 so that those cancel out. So x is equal to 720. I plug this back into either one of these. Doesn't matter which one I plug it into. So since I'm going for y, I'm going to plug it into the second one. So I'm going to use 3,200 is equal to 4 times my 720 plus my 4y. So 720 times 4 gives me 2,880 plus 4y is equal to 3,200. Subtract 2880 from both sides, and it's going to give me, on this side, those are going to cancel out, giving me with 4y, and then I have 320 over here. I'm going to divide both sides by a 4, and it's going to give me that y is equal to 80. So the plane, remember, go back up and let's see here, the plane was the x. So the plane speed is 720 kilometers per hour. The wind has a speed of 80 kilometers per hour. Okay, this one's a little bit more difficult, but because we have to remember this formula right here, distance is equal to rate times time. Setting up this table is going to be the biggest help for you. Okay, so try some of the application problems and then let me know if you have questions.